welcome everybody to another webinar by Lifestyle. My name is Nick Zulfikar. I am the Director of Client Services here. With me is my colleague Ron Hussain. Today we have a very exciting new topic. We're going to be talking about using .NET caching in EF4 through extension methods. EF4 is an object-to-relational mapping engine for .NET and .NET Core applications. This allows developers to generate data access code automatically. They no longer have to write that code themselves. Similar to .NET Core, EF4 is also cross-platform. That means that you can run it on Windows, Linux, Mac, and is getting very popular with the development community. In this webinar, Ron is going to talk about performance and scalability needs in EF Core apps, and we'll demonstrate different strategies to cache reference and transactional data using EF Core extension methods. So before I hand it over to Ron, I wanted to highlight that if you have any questions during the webinar, kindly type them in the questions box on the right-hand side, and I'll be able to jump in and ask those questions from Ron. So with that, Ron, kindly take over and take us through the webinar.
Very good. Thank you very much, Nick, for the intro. Hi, everybody. My name is Ron, and I will be your presenter for today's webinar. As Nick has suggested, the topic that we've chosen today is around Entity Framework Core. We will talk about why Entity Framework Core applications need a distributed caching system. What are the performance and scalability challenges that you would face in a typical EF Core application? And then we'll talk about various options of using caching within Entity Framework Core applications. We'll primarily focus on extension methods, EF extension methods that we have implemented for Entity Framework Core applications. So I'll go through all of the Entity Framework Core extension methods of NCache, and then we'll talk about different strategies to handle reference data and transactional data, as Nick suggested. And we'll also see how to keep data in sync when data exists in two different places when you start using a distributed cache. So that's what we have in agenda for today's webinar. I'll quickly get started. We have a lot to cover. There are lots of hands-on examples that I want to showcase. So let's quickly get started with this. And if there are any questions, please feel free to stop me, ask as many questions as you need to. So first slide is more of an introduction towards Entity Framework and EF Core. EF and EF Core, this is an object-relational mapping engine for .NET and .NET Core applications. The latest version of Entity Framework is named as EF Core. We've recently seen EF Core 2.1 released along with .NET Core 2.1. It simplifies your database programming. It allows you to automatically generate your data access model, so you don't have to write that yourself. It cuts down on the development effort needed for that. You don't have to write persistence code, which you would typically write yourself on an ADO.NET level, and then you have to have mapping between your data model and the object model. So it simply optimizes that for you. So it's very flexible. It's getting very popular with within developer community, and it's cross-platform. And it's very popular in .NET and .NET Core application, and specifically high transactional applications, which are dealing with a lot of request load. This is an architectural diagram of Entity Framework. It also applies on EF Core. There are a few differences between EF and EF Core. EF Core is made lightweight. It has modular approach. There are not a lot of you don't have to go through incomplete installation. You can have a modular approach where they've decomposed it into smaller packages, so you can work with the package that you're interested in. So you don't have to go through incomplete installation for that matter. And they've also gotten rid of EDMX and those mapping files. So with the NuGet packages and there are some commands that you run, and it generates the model for you. And then you simply work with link to entities APIs on the application layer, and overall approach remains the same. Typically, in an EF Core application, we'll talk about the requirements of performance and scalability. Scalability is an ability within an application where you can increase the amount of requests that application has to handle. For example, your user load grows, or those users which are contributing towards request load, that request load grows within an application. And if your application slows down, that application is not scalable. So high performance under peak loads, that's what we categorize as scalability. If your application is performing pretty fine, in a sub-millisecond latency under 5 users, it should have the same kind of performance, same kind of latency, low latency under, let's say, 5,000 users or 500,000 users and a lot of request load. So high performance under high stress load, under peak loads, that's what we categorize as scalability. EF Core, what are the applications which need scalability? It could be an ASP.NET web application, ASP.NET or ASP.NET Core, which may be dealing with a lot of requests. It could be .NET and .NET Core web services, again on the website. Then we have IoT server applications. Again, it could be .NET or .NET Core, or any other general .NET and .NET Core applications which may be dealing with a lot of requests or users in their own domains. So those are the candidates for scalability. So where exactly is the scalability problem? Typically, EF and EF Core, they are deployed on a web form. If it's a web application, they scale linearly. You don't have any scalability issues on the application tier, but they always have to talk to a backend relational data source. It could be a SQL server, it could be Oracle server, or it could be any other data storage that is supported by EF or EF Core. In EF Core, they have a lot of data providers. There's a list of providers that you can choose from. So you end up talking to a database. Although your application tier scales out nicely, but this data storage, the database, relational database, becomes a source of contention. It's slow to start off because it's not in memory. Although EF Core has come up with an in-memory data provider, but that's an in-proc store, and that's for local testing. That eases your testing. But once your application is deployed in production, you have to deal with a relational database which is slow and it does not scale out. It's very good for storage, but it does not scale out when you actually need that scalability within your application. So it's a single store, it can choke down under extreme loads. Solution is very simple, that you start using a distributed caching system like NCache for your EF Core applications, and you use it in combination to a relational database. And here is a deployment architecture of NCache. First of all, it's in memory, so it's super fast in comparison. Then you have multiple servers which are storing the data that you simply usually fetch from backend relational data source. You can bring it into the cache, and it could be your ASP.NET or ASP.NET Core apps, .NET or .NET web services, or it could be .NET or .NET Core server applications. So any sort of .NET or .NET Core applications, or even Java applications, can take advantage of this distributed caching system. It saves your expensive trips to the relational data sources. It's in memory. You can add more servers, and you can grow the capacity of this cache cluster in a linear fashion. So it's not a single point of failure. It's not a performance bottleneck. It's not a scalability bottleneck. So that's the recommended approach to go with it, and that's what we will cover in great details today. How to use .NET caching, and that's going to be NCache as an example product, in an EF Core application through extension methods. Some common use cases of distributed cache: you can use it for data caching, you can use direct API calls, or use Entity Framework Core extension methods, even for EF Core applications, and you save your trips to the database as much as possible. Then on website, the web side of the things, you have ASP.NET, ASP.NET Core caching. It could be a web application or a web service. If it's a web application, then you might want to use sessions. You might want to use ASP.NET and ASP.NET Core SignalR backplane. Response caching for ASP.NET Core. Similarly, iDistribute cache interface is available. View state and output caching. These are all no-code change options for your applications. And then you have powerful pub/sub messaging. You can have topic that you subscribe to, and then you share messages between different applications. Publishers and subscribers can send messages to one another. So that's a general idea. We'll focus more on data caching today within an EF Core application, and I'll walk you through simple steps to get started, and then we'll actually expand more, sharing more and more details on different scenarios. So let's quickly get started with this. First thing that I would like to cover today is application data caching. You have EF Core entities. Excuse me. So those entities need to be cached. So you may see single entity For example, you have a count sum, that's a value, or you could, you're doing some sorting and you get the first customer out of it, or the criteria is such that it's returning a single customer, single product, single order. So that's a single entity, how to cache it. Similarly, we have query results. It could be entity collection. So it's not a single entity, it's a collection of entities. There are two options. You can cache entire collection as one item in the cache, or you can cache each collection item, each entity within that collection separately in the distributed cache. So let's go through the approaches around this. As discussed earlier, you can use direct NCache APIs. NCache API is a key value store. You add data to NCache yourself, and then you retrieve from it yourself, or you can use EF core extension methods and take charge of this, single entity and entity collection. So let me first show you the direct NCache API approach, which is common for all kinds of applications. You can use it in EF core, you can use it in regular EF or any other .NET applications. And then I'll talk about EF core extension methods, which are specifically designed for your EF core applications. And this makes your life a lot easier, where it gets a lot of things done automatically for you, and you just need to call this extension method along with your queries. So I'll show you the both of these approaches one by one, and then we'll focus more on the extension methods going forward. So our first example is caching EF core single entity. We have a get customer method right here. I'll show you this with the help of a sample application that I have formulated for this. So this is our first method. I hope you can see my screen. So we have get customer. It's taking a customer ID, and idea here is that this is returning a single entity, right? So typically with direct APIs, the challenge is that you have to take into account, or something that you have to implement yourself. First of all, you need to have a key, and that key is something that you identify an entity inside NCache, and you need to maintain all the keys in the same format. You can come up with a sample format as shown on the screen. There is a customer keyword, and then the customer ID, and a runtime parameter of customer ID, which makes the cache key. In NCache, everything is stored in a key value pair. Key is a string key, and value is .NET permitted object, and it could be an EF core entity as well. But you formulate the key, and then you use the entity as an object to be stored in NCache. Now you first check whether that key already exists in the cache or not by calling cache.get, and if you do get that customer directly from the cache, and this is a direct NCache API, cache.get, you pass on the key, and if you get that customer, you return the code from here if it's not null. But if it is null, for example, you're executing that query for the very first time, right? Nothing is in the cache as yet. So in that case, you would execute against entity framework core, the link API against the database, and then you fetch that customer from the database and also call cache.insert. Store it with the same key that you formulated, and then customer is the entity that you want to add, and then you also return it. So that's how you would actually deal with a single entity using the direct API. Then the collection could be either a collection as a single object, or again as a single entity. Each collection entry could be a single entity added separately in the cache. So for that, we have get customers by city. So that's the next method. It's returning a list of customers. Again, it's passing the customer city as a criteria. Again, you formulate a key. Again, this is representing a collection of customers based on the city, and then this city could be a runtime parameter here: New York, Paris, London. And then you fetch first by calling cache.get from the cache yourself, and then you check if it exists in the cache. If it does, you return from here. If it doesn't, you simply store it as a single collection. So this list of customer is stored as one object. Other alternative could be that you iterate through the list of individual customers in customer entities and call cache.insert individually as shown right here, right? So single entities and entity collections using direct NCache APIs are going to be cached using these approaches. Now we've covered direct APIs. This is something that you can use in any application. Let's focus on entity framework core extension methods. So same two, single entity and entity collection using the NCache extension methods. So I'm going to introduce from cache. That's our first extension method. And by the way, for this extension method to be used, First of all, you need to introduce NCache NuGet package, Entity Framework Core NuGet package inside your application. So that's a must. If you go to the installed, this is alachisoft.ncache.ef core NuGet package. That's what you need to introduce inside your application. That's one. And then after that, all you have to do is, let me just open the context. So inside the context, you simply call NCache configuration.configure, and it's taking a cache ID, which I'm reading from app settings, and then it's also taking the type of, you know, if you're using dependencies, that's an advanced feature within Entity Framework Core extension methods. You need to provide the type of the data source. But once you've called NCache configure method, there are various things that this method requests, but you can also set up a logger. But that's it. That allows you to start calling NCache you know, EF core extension methods inside your application. So same you know, method, but this time get customer through extension methods. It's going to make everything a lot simpler. You don't have to check data in the cache yourself, and you don't have to call insert explicitly yourself, and most importantly, you don't have to call you don't have to construct the cache key yourself. This is completely automated as part of the implementation of this from cache. Now, from a behavioral standpoint, this is exactly what we've shown earlier. From cache, first of all, takes a caching option, the options, and cache key is an out reference. So it constructs the cache key automatically for you behind the scenes. You just need to call from cache alongside your query as an extension method, and you simply pass on the options of storing that. If you know, it always returns a collection, right? So in that case, you can either choose it to be separate entity or a separate collection, right? So it could be a collection of entities, or it could be separate entities out of that collection. So from cache works in such a way that if an entity, or if a query that you executed and those resulting entities are already in the cache, it would get it from NCache automatically. But if they're not in the cache, in that case, it would automatically execute that query against database, and the result set is returned, and at the same time, it's cached as well. And we also attach the database context for subsequent calls. For example, if you call from cache for first time, it caches it. Next time, same query executes. Obviously, it would execute against the cache, but not the database. But this time, your context, if that was disposed previously, and for this request, you were using the using construct for that matter, the context, if you make any changes in the entities, it also attach those changes to the context. And when you call save changes, all the changes that were done on those entities, which were fetched from the cache, are actually applied on the database. So that's slightly, again, a slightly advanced concept. I'll spend some more time, you know, at a later stage. But just to let you know, the from cache method works in such a way that if something is not in the cache, it would fetch it from the database and cache it. But if something is available in the cache already, it would just return it from there. So this automates the whole, you know, direct API approach for you, where it also constructs the keys. It also, you know, organizes the data in a separate entity or a separate collection automatically. And you just have to call from cache and pass on the out key and options. Same case for collections. For a collection, get customer by city, it would store as a collection, and then again you can call from cache. So that's how simple it is to get started with Entity Framework Core extension methods. Please let me know if there are any questions. Our next topic is around the usage of you know, the type of data in the cache. You could either have reference data or transactional data. Is there a question?
So yeah, Ron, I have a question here. Extension methods of NCache work with EF Core. Do you recommend .NET Core 2.0 framework or .NET framework?
All right, so since EF Core itself can run on .NET as well as on .NET Core, so it's very flexible, NCache extension methods would work absolutely fine. As a matter of fact, I'm running this sample application on .NET Framework 4.6.1, and I have another sample application which is working on, I believe, .NET Core 2.0. So this is .NET Core 2.0. So it works with both .NET frameworks, and specifically it is preferred that you use .NET Core, but it's flexible. It will work for both. I hope that answers your question. Moving on, next segment within the presentation is when you start planning on caching, right? And obviously entity framework, core extension methods make your life a lot easier in terms of caching. So it actually gets a lot of things done automatically. So next question is what data to cache, right? So I've categorized data into two categories. We have reference data, that's the lookup data, and then we have our transactional data, which is dynamically created and changes very frequently. So reference data, a quick example would be products, employees. It's not 100% static data, but it's something which does not change that frequently. But it does change. Frequency of change is not that great. And for this, you should plan on caching entire reference data. All of the reference data should be cached as a must. And then transactional data is a dynamically created data, such as orders, accounts, some workflow processing on some specific collection of data, and the scope of that collection is only for that workflow. Once that workflow completes execution, that data is not needed anymore. And this data can change very frequently as well, so much so it can change within 5 minutes. Whereas reference data is usually a lookup data that may change between hours, 1 to 2 hours, 5 to 10 hours, or even in days.
Ron, I have a question here. How would you identify this cached object when retrieving using EF extensions, just the keys created automatically? Actually, not retrieving, but deleting a particular key.
All right, so we do have, as far as retrieval, we can identify based on, this is an extension method, so the extension method executes along with the EF core. So the return object would be identified on the same lines as your link query would identify it. The question, I think, is more focused on what happens when you plan on updating the records. And for that, we have a set of APIs. We give you a method which allows you to generate a key against an entity. There is a key generation method which we made public. So before making a change in the cache directly, and I'm assuming that this question is more focused on deleting something in the cache or updating something in the cache or removing or adding something in the cache explicitly, we've exposed the cache class, which I'll show you in a bit. And then there is a key generation. Again, you pass on a string, and you use the out reference, and it would and you pass on the entity as well. So against that entity, we use the same approach, and we will give you a key, and using that key, you can identify the object, that entity. If it exists in the cache, you should be able to update it and remove it. I think towards the end, I'll show you an example of how to achieve that. But just to let you know, there are methods which we have exposed to get the key out of NCache as well. I hope that answers your question. Moving on, so we've talked about lookup data and then dynamically created data. So I'll go through one by one, different approaches to handle this. So first of all, we'll talk about reference data in EF core. As I mentioned, this is usually a lookup data. So there are two things that you should do as a must. You should first of all load entire reference data into the cache as a must. And motivation here is that this data is something which is not changing that frequently. It's a product catalog in an in an e-commerce application. There are some discounts on certain products. While that discount is enabled, let's say for 3 days, those products may not change. So it's better to cache all those products into NCache and save your expensive database trips to that extent as much as possible. 100% data should be loaded in the cache, so that you don't have to go back to the data source. And then always cache them as separate entities. Why? Because products, the entire data set could be thousands and thousands of products. Let's say Northwind database products could range something from 50 to 100,000 products. But you may only need, let's say, 10 out of those or 100 out of those for a given request. So if you store them as separate entities, you're able to run link queries. NCache also supports link on NCache directly. So you're able to run link on getting the subset of the data, querying the subset of the entities out of NCache as well. So these are two rules that you should follow as a must. And I have an example, and here I'm introducing our second extension method that's called load into the cache. Now this works in such a way, and this is targeted for reference data only. This is a preloader into the cache. So the motivation here is that you should call this method, let's say load all products, and you should make sure that you're storing it as a separate entities, and you should run a query which says from products in the database products and select products. So you're not specifying any criteria. That means that this would load all 60,000 products into the cache, and then you're using load into the cache, right? When you say separate entities, you just need to pass on this option, and it would just create a separate entity for each product in the cache. And this is again a preloader, right? You should preload this cache. There are two options. You can run a separate application for this, which can take responsibility of preloading the cache. This could be application startup or a separate application, or it could be a cache loader implementation of NCache as well. There is a cache loader, and in future releases, we're also working on cache refresher. The responsibility of cache loader is that it actually runs at your cache startup, and then it makes sure that all the data that you want to load into the cache is loaded as part of that. It's your implementation, but NCache simply calls it. But like I mentioned, you can come up with a method like this and make sure that you call it once at your application startup, or have a separate application do this and share this data across all your application instances. Now, once this is done, how to query data out of the cache. And that at that point, I'm going to introduce my third extension method, which is from cache only. So first extension method was from cache, which was if something is in the cache, get it from there. If it's not, automatically go to the database and fetch it. Load into the cache always executes against database. It's never executed against cache, although it's returning, but this is returning from the database as a must, so that data set is refreshed, a new data is loaded, and then it's also caching it. And then from cache only is only executing against NCache, because this is designed only for the reference data. So for reference data, you would use a combination of load into the cache, so that all the data set exists in the cache as separate entities, and then you would call from cache only, so that only data set that you're interested in, that's discontinued products in this case, is brought only from the cache. So you don't have to go to the database at all. And we'll talk about how to keep this data fresh when data changes in the database. So I hope this makes sense. Let me show you this example right here. So I'm calling this method right here, and then I'm returning a list of products, discontinued products, by using a simple EF, the link API directly on NCache entities. So this would not execute against database at all. This would execute only against cache, because I'm using from cache only extension method. I hope this helps. We've covered 3 extension methods from cache, which is more of transactional data use case, and then we've covered load into cache and from cache only. For reference data, you should focus on using entire data, using load into cache, and then separate entities. And then for queries, you should use from cache only. Next, we'll talk about transactional data, and then we'll talk about how to keep this data fresh for both reference as well as transactional. Please let me know if there are any questions at this point. Now, transactional data is usually a working set. I've already covered that it's a dynamically created data. It's only needed for a current user, current request, or a workflow is executing, and once that is executed, you may not need that data anymore. So chances are that only the instance of the application which actually retrieved that data, those entities, are needed only by that instance of application. So it doesn't make sense to store all your transactional data in the cache. It's not a requirement. You should only cache the working set. So that's step number 1. So you should cache query results. You can fetch most readily accessed entities. And second step is, there are 2 options, 2A, 2B. You can cache your transactional data as an entire collection. That's a preferred approach. Usually you need entire collection always, because you're working on it. And then you can also store separate entities as well. It's entirely up to you. And this is for the scenario where although you've cached a collection, but you still store it as separate entities, because you might need only 2 or 3 entities out of that collection. So it's better to have a granular approach when storing the collections. And we have get customer orders. Orders are pretty transactional data. There must be a processing unit which is dealing on certain orders, and chances are that each workflow which is doing that has its own set of orders. So I'll show you this example real quick. So it's working in such a way that it's putting a lot of caching options. Let's not actually go into details here. Store as collection. That is how you choose to store it as a collection, and then I'm using from cache only. The reason for transactional data I'm using from cache, because data can exist in the cache, and if it does, the entire collection, I just need to use it. I don't have to go to the database. But if it doesn't exist in the cache, and this data changes very frequently as well, we've also set up an expiration on it, let's say 30 seconds. So you might want to go back to the database. If you use from cache only, you can return a null value if it doesn't exist in the cache, if it has already expired. So for transactional data, use extension method from cache. For reference data, use load into cache to preload, and then use from cache only. So that's the approach to go about it. And then for separate entities, all you have to do is store, call this. Let me just use this. And instead of using a separate entity, just say, I have to comment, should have commented. Right, store as separate entities. So that's all what you need to do.
So Ron, while you're going over this, there was a question in the previous example of querying reference data. Is there any indexing? Because normally that's what you would do on the database.
Absolutely, that's a very good question. And for reference data, since it's executing against cache only, this link query requires that your product and the attribute along which you're running the link query is indexed. And as a matter of fact, I am using index data, and it's very simple to index. You just need to provide the type, the model, and then provide the attributes that you need to index. So these are index attributes, and we are indeed running queries against index attributes. I hope that answers your question. Please let me know if there are any other questions. Otherwise, I'm going to move on to our hands-on portion real quick, show you the actual product in action, and then the most important segment of this webinar, how to keep cache data fresh in comparison to database, and also in regards to reference data and transactional data. So please let me know if there are any questions.
No questions so far.
All right, so I'm going to open a new project just to. All right, so the hands-on demo portion, I will quickly show you the actual product in action so that you know how our distributed caching looks like, and then we'll run the application against it and show you how to keep it fresh, the data in the cache as fresh. I've already installed NCache on 2 of my boxes, 107 and 108. I'm going to use these as my cache servers. And my personal machine right here, my laptop, is going to be acting as a client. So first of all, I will launch the NCache manager tool, which comes installed with NCache, and I'll create a cache. Let's name it EF core cache. I'll use 2 servers, keep partition replica as our caching topology, and then asynchronous replication option because it's faster. And here I specify the servers which are going to host my cache. So I have 2 servers, demo 1 and demo 2, and TCP/IP port for communication. It's everything driven by TCP/IP as far as communication between servers and clients are concerned. Size of the cache based on the data that you plan on caching. If it's reference data, you should take into account that you're loading all the products, all the customers. Similarly, if it's transactional data, you need to account for working set and some more room for that as well. Keep everything simple, choose finish, and that's it. That's how simple it is to get started with NCache and configure a cache. Since I'm running applications on my machine, so I just need to add my box as a client machine. I can start and test this cache cluster, and after that I'm good to go run the sample application to connect to it. So that's how simple it is. We have a regular NCache architecture and scaling .NET apps webinar in which we talk about these configurations in great details. So if there are any questions, you might want to look into those webinars as well. I'll show you some monitoring aspects as well, statistics window, and then I'll open NCache monitoring tool so that I can actually run the stress testing tool application, which comes installed with NCache, and see things in action. So this is a stress testing tool. I'll run it against this because my box is a client, so I can simply provide the name and it should connect to this, and I should be able to simulate some dummy load on my cache cluster. So there you go. About the cache size is growing, items are being added, and requests per second load is also showing activity on both servers. And then this monitoring tool, I think it's taking time. It's creating dashboard. So let it roll. And in the meantime, let me run another instance of this tool from the server itself. All right, so you can see the increased amount of requests per second growing. For some reason, it's taking some time to load the dashboard, the monitoring tool. I think I'll leave it right here. As soon as it comes back, I'll show you the monitoring details of this tool. All right, our next segment within this webinar is keeping cache data fresh within an entity framework core application. And for this, I'll again use reference data and transactional data example. So we'll start off with reference data. We've already established that in order to cache reference data, you should cache entire data set in the cache. For example, you have products, you should load all products in the cache and then load them as separate entities. Then what is the issue with this? Since reference data, the entire reference data in the cache, and then you only use cache using from cache only extension method. Now you don't want to afford a partial data set out of the cache. If it's discontinued products or you're running some criteria, you want all those products in the cache. But there are chances that those products actually change in the database. Now data exists in two different places. You have database, which is your master copy, and although you loaded entire data in the cache, there are still chances where database gets updated outside the scope of your applications. So in order to keep cache data fresh, you need to ensure that you have some kind of mechanism which updates the data in the cache automatically. And for that, we have two options. Option number one is that you use expiration. This is a time-based expiration. And then you mix it up, you use it in addition with auto reload feature. NCache expiration feature allows you to expire data, remove data after the specified period of time, let's say 5 hours, 10 hours. And with reference data, since it's a long running data, it's a lookup data, master data. So frequency of change is not that great. So you can come up with a comfortable number of hours or it could be 5 hours, 10 hours, 24 hours. So based on that, you can set up an expiration time. But as mentioned earlier on, you don't really want to lose or remove that data out of the cache. What you really need is that the data which gets changed, let's say 10 products are expired based on the expiry of that you specified, it should automatically reload that data into the cache with auto reload mechanism. And NCache provides you that with the help of a read-through handler. So all you have to do is, again, load entire data in the cache using load into the cache, use separate entities, but alongside that, use these two characteristics, such as set absolute expiration. That's the expiration value that you would set to all the products which are going to be loaded in the cache, and then you set resync provider, which essentially calls your read-through provider within NCache. Read-through is combined with expiry, so instead of removing data out of the cache, it actually reloads. Since it knows all the keys and all the database related information, we just need you to pass the context, and based on that context, we actually call your provider automatically and resync. We get the updated value from the data source. Let me show you a working example of it. Here is a method. I'm storing this as separate entities. Typically, I would set an expiration of 5 hours. But since we don't have that much time, so what I will really do is I'll set up a 30-second expiry, and I will put a breakpoint right here, and I will load all the products into the cache. I would not set up a resync provider at this point, just to show you how expiration works. And as soon as the expiration comes into play, it will remove the items from the cache. And then I'll show you how to take care of this scenario in such a way that instead of removing, just reload using the read-through handler. So I'll use the local cache for this sample bit. I'll just clear the contents just to be on the safe side. And then I'll run this piece of code and hit the breakpoint. Right, so it has 30 seconds of expiry, and I will just hit, and I got the discontinued products. Right, so we have all the products here, and we have about 1,000 entries here. After 30 seconds, these 1,000 items are going to be expired based on this absolute expiration flag that we've set up. And I'll run this query again, and you would see that it would not return anything because nothing exists in the cache. It's using from cache only. So it would just, we have items expired. I'll run this one more time, and you would notice that I got 0 value. So this is not what is recommended or what is preferred. Considering this is your reference data, entire data is already loaded in the cache, and you're calling from cache only extension method. So you need all the data available as a must, not the partial response or missing data. And at the same time, this should be reloaded after your expiry. Instead of removing, it should reload. And that's exactly what we will do with the help of this set resync provider name. I have a sample resync provider, which is right here, iRead-thru provider. What it really does is, we have given you a default implementation of this. This is our iRead-thru provider. All you have to do is, let's show this with the help of the cache that we've configured. You have to set up the read-through handler. For example, let me just create a new cache. Let me just create a local cache. Right, so it's just a local cache. I'll just set up a backing source, enable read-through, add, and let's say EF default. And this needs to be set up. And I can use this as a project. And the implementation is already done. It works in such a way that I've implemented the iRead-thru handler. This is the default resync provider, right? It has some methods. It has initialization, where you initialize the DB context, load from source, which is called on expiry, and inside this I'm getting the item from the database. If I go inside the definition, it actually takes care of all the database related calls. And this is something that we're providing as part of our implementation. Our NuGet package covers it as part of it. So we're getting the key, and based on that key, you pass on the context, and the context is used to obtain the actual object directly from the database. All you have to do is, inherit, implement this EFD default resync provider, and give your own implementation and give us the database context. So this is a abstract class that we have given you. You just need to give your Northwind database context, or any database context that you have. And based on that, once this method is overridden, implemented, you simply register this with your cache. For example, this is our resync provider. If I open this, it contains two of those. One is default and other one is your implementation. And you can pass on your connection string and other information if needed. And that's it. You simply deploy this. Let me just take it to this bit. And it will just give you a success on this. So that has to be done. Like I mentioned, that this is already done as part of NCache implementation. It has the NuGet package comes with a resync provider, which you can simply implement by implementing this particular method here and giving us the context. And rest of the job is done by this sample default resync provider, which actually works on the same lines as extension methods work. We construct your key, so we know which key represents which entity, and based on that entity and that key information, we actually query the database using the entity framework APIs. Now, this has already been done for my cache. What I've done here is it has successfully deployed. So for my cache, I've already done this. I have this EF default and I've deployed it. So I'll run the same use case, but this time instead of simply expiring it, I would actually reload it. So that's what I'm going to do. All I have to do is set up the resync provider name, and then since I'm planning on updating some values as well, so I'm going to use 60 seconds. Typically for reference data, you would have a lot more time specified as your absolute expiration, such as 5 hours or even more. So I'll just run it with 60 seconds, and this time my resync provider is set up. So I'll run this use case one more time and show you how this gets updated instead of expiry, instead of removing. So this has run, and hopefully it will come back to this point. All right, so we have products loaded. I'll run this one more time, and in this time, since it has a 60-second of expiry, I'll update this particular product ID 17, and what we'll do is we'll just say updated. All right, and although it's updated in the database, it would not be updated in the application context as yet, because it's only using cache data and it's not expired as yet. So we'll keep getting the older values. And if you notice on my cache, we have 1,000 items, and there's a read through per second. This would show some activity after 60 seconds, and it would automatically call the read through handler that we've just set up. So let me just run it one more time, and I'm expecting older values again, if not reloaded already. But there would be a point where it would just reload, and after that it would simply, instead of expiring, it would just reload the 999 of the products. There's one item which is extra, that's usually a reference. There you go. So it's instead of expiry, only one item got expired because that's a list of keys. Otherwise, all the reference data based on my query, let me show you the query, it says where product ID is less than 1,000. So that actually represents 1,000 products. So I'll run this query one more time, and this time, since the data has been already updated on expiry instead of removal, so I'm expecting the updated product to be added in the cache. So there you go. So my product has been updated as part of this. So this is what we recommend as part of our option number 1. So you use expiration but with auto reload feature. So instead of expiry, you simply reload data, and this would take care of keeping cache data fresh. So you come up with a comfortable time that allows you to keep data in the cache. You keep getting older data, and as soon as that older data is about to be expired, that could be a day worth of time, let's say 24 hours. It could be 2 days, a week, whichever is comfortable time within your application. It could be some hours as well. And after that, it would just reload that data in the cache. So that's our option number 1. I hope it was pretty straightforward. Option number 2 is that you don't use an expiration. So that would just take care of this problem right here, where data would always exist in the cache. But data can be stale in the cache, and it could be stale forever. For that, you should manually reload, and that's very simple as well. All you have to do is you simply need to call this load all products after a periodic interval. For example, if we come back to this bit right here, so this method needs to be called after some intervals. And again, as mentioned earlier, this is usually done at your application startup, and it could be one of the applications which is taking charge of it, which is taking care of all this. So it could be either that, or it could be one of the applications, a separate application which is doing that. So it could be your application, one of your application instances, or it could be a separate application altogether. And that application can periodically call this method after, let's say, 5 hours, 24 hours, again, which is your comfortable time after which you want this to be executed against database, and you want your products to be reloaded. So load into cache would take care of that particular scenario, where it would execute against database and load the fresh copies into the cache. So that is how you take charge of reference data. I hope it was pretty straightforward. Let's move on to the next segment, where we use transactional data. Now, transactional data is something which is short-lived, right? It's a working set, as explained earlier. So you may use 5 to 10 minutes of expiration. So what you really need to do here, since you're using from cache, which executes against cache if it exists in the cache, and if it doesn't exist in the cache, it would always execute against the database automatically. So this is built into this extension method, unlike from cache only, which you use with the reference data scenario, right, which only executes against the cache. So it's okay to have some data available, whether you stored it as a collection or as a separate entity. So you simply use short expiration, let's say 60 seconds. Although I used that example for reference data, but that was for the sake of this particular demo. But for reference data, you usually have 5 to 10 minutes, 5 to 10 hours of expiration, and for transactional data, you have somewhere between 60 seconds or related, expiry attached to it. And since you're using from cache, let's actually have a look at the get customer orders. Since you're using from cache, that should allow you to use the, Let's actually take this as example. Right, so you set up some expiration here and you call this from cache extension method, and that should take charge of getting it from the database if it doesn't exist in the cache. And after some time, whether your working set is active in the cache, you would get it from the cache. If it's not active in the cache, chances are that it's not needed anymore, right? So you may end up going back to the database, and that's the right thing to do with transactional data. So I hope this covers our reference data as well as transactional data scenarios and how to keep cache data fresh in regards to these two. Please let me know if there are any questions. Otherwise, I'll move on to our next segment, which is handling relationships in cache.
So Ron, while you're going over that, I have a couple of questions here. Does the NCache or does the cached items reside in the NCache server, or they're shadowed in each application server?
They reside in NCache, right? So the items actually exist in NCache, right? So the actual repository is maintained within NCache, and we actually construct the keys and objects alongside these entity methods. So that's the idea here.
Okay. Another question is, can we have multiple cache loaders configured, or all of them need to be configured into one when we're adding reference data to the cache startup?
You can, because load into cache is a generic method, right? So it actually loads whatever the query that you're planning to run, right? So it's bound to the query. You can have multiple of load into cache, and there could be one separate application, or it could be different places within the application. So it's very flexible on that end as well. There are a few important concepts that I want to highlight. How to handle relationships, one-to-many and many-to-many examples. Let's focus on one-to-many. If you have, let's say, regions, and then there are territories which are part of regions, and there is a one-to-many relationship going on between regions and territories. Let's go to the sync approach, and inside, actually let's get the regions from here. All right, so get regions with territories. The basic idea here is that you have include keyword, and then you use from cache, and you always store it as a separate entities. The idea here is that the parent item, the region, is going to be stored as a separate item in the cache, since region also has a one-to-many relationship with the territories, and there is a collection of territories inside each region entity. So NCache would obey that. As soon as you call from cache, it would simply get the region, and all the regions are stored as separate entities, and based on the scope that you specified. And all the territories, with the help of from cache, are going to be stored as separate collection inside each region. So it's one entity having a many side, the collection side, as a related object. So that's how you tackle one-to-many use case. Then you have caching aggregate operations. You can result into an entity or result into a value. For example, getting a first or default shipper, right? So that is something, let's say, if I just do a first or default here, this would fetch me the first shipper, and then based on this is going to be stored in NCache. And similarly, it could be count, sum, it could be any aggregate operations, so it could be a value. Again, this can be stored in NCache as a separate entity. So this covers our webinar as far as technical portion is concerned. Towards the end, I'll show you some distributed caching architecture. NCache as a product is very scalable, fast. It's something which is based on peer-to-peer architecturing protocol. There's no single point of failure. You can add or remove servers on the fly from a running cache. You don't have to stop the cache or any of the clients which are connected to it. So dynamically you can make changes to a running cache cluster. Then our most popular topology is partition replica cache. This allows you to simply distribute data on all servers in the form of partitions. So they're pooling the memory resources, computational resources together, and that presents you a logical capacity, and each server has a backup as well. Server 1's backup on 2, server 2's backup on 1, and server 3's backup on server 1. So in a round robin fashion, each server has a backup on another server. Similarly, this is very fast, very scalable, most popular topology. You can also have a client cache which can run on your own application box. It's a local cache, but it's in sync with the server cache. Subset of the data would automatically be brought into the cache and without any code changes. This improves your performance if your data is mostly of reference nature. So once you load into cache and then you start calling the subset of the data by calling from cache only, client cache would really help in that case. WAN replication is another feature. The bridge replication, you can have active passive or active active data sites. All the data, the AF core data, ASP.NET sessions or regular data can be transferred into the target site across the WAN in an active passive or active active manner. So this is what NCache covers as part of it. Some list of customers, and this concludes our presentation. Just to reiterate, I'll take one more minute before I hand it over to Nick. So we talked about single entity and storing entity collections using direct APIs. That was slightly different in terms of extension methods. And then we talked about extension methods, which were very simpler in nature and more flexible in nature as well. From cache was first method, which fetches something from the cache if it exists. If it doesn't, it automatically fetches from the data source, unlike direct APIs where you have to implement it yourself. It also constructs the keys and related options that you set up here. Then we talked about reference and transactional data. For handling reference data, you need to load entire data using load into cache, and then you should call from cache only. Load into cache always executes against database, and then from cache only executes against the cache. And then we talked about transactional data that you can handle with the help of from cache, and you set up some expirations. Reference data, in order to keep it fresh, you need to use expirations, and then you use auto reload, or don't use expirations, or use and then manually reload using load into cache. And then we talked about transactional data that you need to come up with some kind of expiration and use from cache, so that if it exists in the cache, you get it. If it doesn't exist in the cache, you always get it from the database. So that concludes our presentation. Please let me know if there are any questions.
Well, thank you very much, Ron, for this insightful presentation. And guys, if there are any questions, kindly type them in the questions window, and I'll be able to get those answered for you. You can always reach us at support@alachisoft.com if you have any technical queries. You can also reach us via sales@alachisoft.com. If you wanted to take a look at it, download the product, you can go to our website, alachisoft.com. You can download NCache, and it comes with a 30-day trial version that you can use. And if there are any questions, let us know. Otherwise, thank you very much for attending the show today, the webinar, and we'll see you next time. Thank you very much, Ron.
Thank you, guys. Thank you.